Live. It looks like it. Yes, we are. Okay. Everything looks like it's streaming. Alrighty then. Well, we have another week. It is the week after the daylight saving time has ended. And I don't know about you guys, but I'm feeling a little. How you guys feeling? A little run down, a little bit tired as we head towards the evening because mostly we're used to it being like around 9 o'clock. And instead, it's 8 o'clock and it gets darker earlier. So I personally, I like going to standard time, but at the same time, definitely is a difference in terms of the energy at night. So if I seem a little bit flatter than normal, I do apologize. I'm gonna power through it and drink plain water. Is everything okay?
Yeah, it's fine.
Okay. All right. Anyway, everything overall is getting pretty interesting. So let's dive right into the data and take a look at what we have here. This is the big theme that's been bouncing around social media the past 24 hours. The new MEI values have come out. This is version 2. Let me explain. Let's read over what this is. And you can go right to psl.noaa.gov. Okay, free website again, easy to find. And you can research all of this information. But basically, the MEI is created by using 5 variables, which is sea level pressure. Remember what I was talking about with the SOI? Sea surface temperature, surface zonal winds, surface meridional winds. I can never say that right, even in college. Outgoing long wave radiation, to produce a series of conditions to compare, right? So all the talk was about, oh my God, we're going to have a super strong El Nino. And in reality, what we have in terms of our observations is anything but. I mean, here we have 2016, here it's 98. You can see back here in 1981, you see all the really impressive historic El Nino events. And you can see comparatively to ours, it's puny compared to what we're seeing here. And the current value is right now 0.3, which is actually below what you would normally expect for an El Nino. So what's happening? Does this mean El Nino's collapsing? Does the forecast for a strong El Nino pretty much fall apart? Well, if you base your whole forecast on just the sea surface temperature anomalies and just saying copy paste strong east base El Nino and then walk away, yeah, your forecast is in a little bit of trouble, because what this is telling us is the atmosphere is not reacting to or evolving in such a way that you would say strong El Nino. It's nowhere near it. Okay, this is the chart in comparison to 83, 87, 92, 98, and 2016. All of your strong El Ninos that a lot of people were using to compare, especially 92 and 98. You know, everyone was pulling up 98. We're nowhere near that in any way, shape, or form up to this point. And it doesn't look like we're getting anywhere close to those values as we head into the winter months. So this is very important to understand the forcing mechanisms in the atmosphere. If we don't understand these fundamental forcing mechanisms, you can't really make a seasonal forecast. So why is this the case? Well, clearly, when we take a look at our sea surface temperature anomalies, and if that's the only thing you looked at, you would see this and say, hey, look, this is an east-based strong El Nino event. You have your warmest conditions still in Nino 1+2. It's moderating, and you're seeing a shift more towards a basin-wide, but clearly the warmest conditions are in your east zone. Case closed. Have a good night. I'm going to walk out. That is what some people would like to do. But we know that the forcing mechanisms have not acted like that. So why is this happening? Well, part of this happens to be a subsection of what we would focus on with climate change in terms of the water temperatures in the Pacific. Now, when you compare what's going on with these water temperatures now to 1998 or 1983, it's not really comparable. Okay, you're for one, you had much colder sea surface temperatures in the Central Pacific and Northern Pacific. So that would allow for more of a focus of this warm water to basically shift all your convection to the south of Hawaii. And that would lead to a screaming subtropical jet stream heading up the East Coast and setting up a rather mild, progressive, wet winter for much of the eastern United States and a chilly, raw, wet one over the southeast. But what we have is this gradient here. And this gradient is strongest here. And what that leads to is your SOI values remaining more of a weak area, which is what we've been talking about for quite some time, right? We've been focusing on this data as part of the winter forecast saying, hey, look, this is not anywhere near a strong El Nino in terms of the atmospheric reaction. We need to acknowledge this and make sure that we adjust our forecast as such. So we consider that factor, and then we take a look at what the MJO has been doing. Now, the MJO is overwhelmed in terms of the influence by El Nino. Okay, if you have an El Nino or La Nina in place, the MJO more is a bellwether of where the convection is going to lead, not so much as a driving mechanism for the entire pattern. But what this bellwether is telling us, what this little signal is telling us, this bird in the canary mine here, is that it continuously is focused on phases 7, 8, and 1. Phases 8 and 1 typically has a lot of your convection around Africa, the portion of the Atlantics, around the Eastern Atlantic, and also around the dateline, and sets up the potential for storms on the East Coast and an active weather pattern, right? So where's all of our convection? And it's been like this for months. This isn't something where, like, hey, look, the observations just came up this week or the past couple of weeks. This has been going on since March. Okay? It really took hold in May. And has been continuing all through the summer, through the fall, and now as we head into winter. So this isn't something where hey, this is new or we'll see if it gets sustained. This has been sustained. The driving mechanisms remain sustained. And when we take a look at the forecast of the MJO on a variety of models, you can see that either the MJO is forecast to remain in a neutral state, which means that El Nino is in control, or a very weak state in phases 7, 8, and 1, which basically means more of the status quo of what we've been seeing. So does that mean snowstorms for everyone? Well, slow down for a minute. We still have a lot to consider here. Okay, now we already know what the winter forecast is, and we already know what we're going to be looking for. One of the things we are studying is the snow growth, right? And the snow growth has really been expansive now. Okay, it certainly has grown at a steady rate, allowing for a strong support of our polar air masses and Arctic air masses to grow over the North Pole, over Siberia, and over North America. But at the same time, we also see that the QBO remains in easterly phase. I don't really see that changing all that much. And our polar vortex is strengthening. Oh, wait a minute. Isn't that a fly in the ointment? Kind of, but not really. Okay, so the winter forecast stated December is going to be our mildest month and our lowest chance for any type of winter storms. And I know that there's a lot of people who are looking for that storm to pop up in Thanksgiving or around Christmas and whatnot. So I'm going to say this again before we go any further. The northern mid-Atlantic has less than a 10% chance of seeing a quote-unquote white Christmas on a good year. Okay? El Ninos typically really start rocking and rolling in terms of the winter pattern by about January, more like after January 10th and continuing on through February and into early March. Why is that the case? Well, part of the dynamics involved with an El Nino and the way that it transports heat from the tropics to the mid latitudes and the higher latitudes, are also pushing up into the upper troposphere and stratosphere, is such that the polar vortex really doesn't get its disruption and weakening until we get to late December, and then we start to see in January, and then you get your big flip, right? As textbook of almost every El Nino pattern I've ever been in. Now, that doesn't mean you can't get a winter storm in December. I'm just saying that you're less likely to see it, okay? When I'm studying the polar vortex, this is pretty much what you usually see in El Nino. The polar vortex starts to strengthen, but there are signs that are showing up that have my interest. Part of that is that as it's strengthening, it's also introducing a sign of stretching and stretching towards North America. Now, when you combine this signal with what we're seeing with the QBO, and we know what an easterly phase does, it tells me that we need to keep a very careful eye on heights starting to build, especially after early December around Greenland and around Scandinavia. If we start to see 500 millibar heights building in this area here, then we'll see a pretty significant disruption of the polar vortex and everything cascades down. So that's going to be the signal I'm going to be looking for to study and to say, like, okay, this is where the pattern is going to start to shift. This is where we're going to see that. Now, does that mean that we won't see any type of storms? Well, let me just show you some of the teleconnections. This is important to study. We'll use the European guidance out to 46 days, okay, just to kind of give you a theme. This isn't the pinpoint, but just give you an overall theme. The overall theme with the Arctic oscillation, as you would expect, is generally positive as the polar vortex evolves. North Atlantic oscillation would pretty much be about the same. Okay, this doesn't mean that as we get closer, you see a dip here and there, and you can pop off a storm because of that. But the overall theme, we're looking at the overall theme. But we also have a negative EPO showing up quite a bit. So this tells me that we will see an interaction between the polar and subtropical jet stream as we move through the rest of November, especially in November and December. The problem here is that when you take these teleconnections and kind of get the theme here and look at what they're saying and what they normally produce, what this tells me is you have transient cold air and a pattern where you have to have perfect interaction with the short waves to set up any type of storm. So this is where it becomes difficult to pull these things off. Combined with the fact that our sea surface temperatures around the northern mid-Atlantic are typically warm, which is another reason why it's difficult to get snowfall on the coastal plain or even in the interior. And at the same time, it's hard to get sustained polar air masses in this type of environment. So what does that look like at 500 millibars? Well, this is what the European looks like on the 46th day at 500 millibars. And again, you don't take this as a specific forecast or a detailed forecast, but at the overall themes. As we move through the forecast and as we move through December, what do we see? Well, this doesn't support high latitude blocking, but this shifting northward has my attention. We'll see what happens with this higher heights here. We'll start to see some idea, maybe a weak ridge starting to show up here. But more importantly, we have this ridge on the west coast, a trough around the east coast, so certainly stormy conditions possible. And in terms of the Thanksgiving time period, again, now we could be a little bit more specific when we take a look at what's evolving here on the European, on the GFS, And what I'm seeing is a fast moving pattern for the next couple of days, a progressive pattern. But as we head towards Thanksgiving, if we study the European and the GFS, what I really like here is a fast moving storm potential with the potential interaction of maybe a rainstorm, maybe a little bit of snow over the interior. Now, how does that show up? Well, again, what we're going to be looking for is our jet stream to buckle. And you're going to see that buckling first in the subtropical jet stream and the trough building in, and our ridge building along the east coast, along the west coast, and setting up a deepening trough. And let me pull up this data here. And so what that generally looks like is this type of storm here. Now, again, we're not looking at specifics here, but what I'm just trying to point out is we have a storm coming through here with a wave of low pressure over the Great Lakes, another wave of low pressure around the Mid-Atlantic. Maybe you get some snow over the interior, but certainly I would say look for an active pattern as we head towards Thanksgiving. But that's as much as I'm going to go as far as any other details. But certainly, if you are traveling around Thanksgiving, I'd definitely be prepared for that. As far as the pattern for the next couple of days, well, first of all, we had our couple of reports of snow and sleet, especially around northern New Jersey and right around this area here. And that was with this band of precipitation here. I've been warning in the past couple of days. I wasn't expecting much in the way of accumulation, but beware of a little bit of sleet and snow mixing in, and we are getting that in the observations as I saw on X, where just enough to create maybe a few slick spots on some secondary roads tonight. So if you're traveling tonight in this area here, just use some caution. But at the same time, the warm air transport is very strong. When you see packing like this, that sets up a pretty strong thermal gradient. And as the heights and as the winds start to align here, we're going to get that warm air really to surge northward and setting up a rather warm period of weather for tomorrow. Not expecting a lot of rainfall, and that's because we have an awful lot of dry air at 850 millibars. When you see this signal here, that means that you're pretty much going to have widely scattered isolated showers and a lot of virga. So not really looking for a lot in terms of precipitation. Our water vapor satellite picture shows that the strongest lifting is clearly lifting up towards New England. And that's also showing up very nicely here in the lifting. Again, in this type of pattern, when the polar and subtropical jet streams are not interacting just right and they're off by a little bit, this is where you start seeing this sheared shortwave influence here and a lot of weak, pesky low pressure systems producing a hit and miss shower, but no significant storms really are on the horizon over the next 10 days. We do see a little bit of chilly conditions as we head towards this weekend, but nothing that is well out of the ordinary for what you would expect for this time of year. And then again, the Pacific pattern just continues to remain in control with the Pacific air mass running from coast to coast. And that's showing up very nicely here in all of the guidance. And that's why we're seeing these little weak low pressure systems, pesky shower here and there, but no major storms. So that is the general pattern going on right now. Let's take a look at some of the questions we have here. Looks like we're busy here on... Wow, we have a lot of questions from both on YouTube and on here. So let's take a look at what we got here. Let's see here. Oh yeah, I did misspell evolving into the long range thoughts. My apologies. I gotta fix that later. But yes, Card, I did write that wrong. I find this would, you know what happens? This is what happens when you start working at 5 a.m. and you just keep going straight. I find the switch in fall a lot easier to deal with than spring. I agree with you. Going for spring, I feel like someone just kicked me in the head. You know, I feel I get more headaches. I don't like it at all. In the fall, it's more that I just get run down towards the evening. because my body is like, hey, we should be in bed. And I'm like, no, I still got an hour more worth of work to do. So that's why. But all in all, I just wish that they pick one and stick with it and just leave it alone. Because the switching just doesn't do it for me. I know there will be a warm up for part of November. Yeah, pretty much most of mid-November. Do you see temperatures around this week getting into upper 60s to 70s in New York City Metro and F5 area again, or is lower to mid 60s much the top of possible warm days? I definitely can see a couple days in touching 70. I can't rule that out. When you have the subtropical jet stream involved here, like it is, you definitely are going to have the ability to pull up air masses from the Gulf of Mexico. And so you could push your 850 millibar temperatures to around 12, 13 degrees Celsius pretty easily. In fact, when we take a look at the observations here, I mean, there's your 10 degrees Celsius, 21 degrees Celsius in the Ohio River Valley. Over here, let me see if I can pull that up. You can see that right there. So, yeah, I mean, certainly, and the reason why this is a possibility is just because of the nature of the pattern. Right now, this is a pattern where basically you get a low pressure system cutting up towards central Pennsylvania or even on the East Coast, but it pulls up a lot of warm air, and then the cold air falls in behind it. So you get these rapid warm-ups and then crashing of the temperatures. Can't recall seeing the Southern Pacific south of ENSO region, especially southeast, so cold. Let's see here. Oh, you mean down here? Yeah, I mean, it's very interesting. There's actually a lot of research going on down here as far as what's going on with the sea surface temperatures, because that was not modeled by a lot of the climate models. So they're trying to figure out, hey, what exactly is going on here? It could be a matter of changes in the way that the water currents are developing. We don't know, which is why I never talk about things in terms of climate in terms of absolutes. We understand what forcing factors can do, but there's a lot we don't understand about the atmosphere still that we are always studying. So it is wise never to do absolutes. It's also wise never to ignore the data either. So some very interesting evolution down here that we're trying to study and figure out. Impressive positive IOD here. Impressive again with our ENSO event. With this gradient here really just kind of shaking things up. And again, we really don't have... I know that people like to focus on the PDO. We really don't have a signal here. I mean, it's pretty much just warm across the board and, a little bit of cooler water here and there, but nothing sustained like a true PDO event. Looks like December lake cutters were cold after the precip is over. Yeah, I definitely see that as being a theme for a lot of the month. I know that there's some people that really want to jump the gun and talk about major storms in late November and December. I've been seeing that quite a bit on X as well. And it just doesn't match the climatology of what you would expect even with a weak El Nino. Typically, this time of year in December, it's really, really hard to pull off the pattern because, remember, El Ninos, in terms of winter storm potential, is driven by the interaction of both the polar and subtropical jet stream. And if they're not aligned, they basically shear each other apart. So it's really hard to pull off that scenario, which is why we typically see it later on. Let's see what we got in YouTube world. Wow. There's quite a bit. Let's see here. All right. Why do people pay so much attention on Nino and barely anything on the Atlantic water temperatures off the New Jersey coast? Specifically, wouldn't that have a big say? Okay. The Pacific has a really, really important influence on the pattern overall, because you have a lot of this water. And remember, the weather pattern goes from west to east. Does the Atlantic matter? Absolutely. Okay. The Atlantic matters, especially along the East Coast, because if you have very warm waters here, then you have a lot of rising motion, and it increases the potential for dynamic storms, which was talked about in the winter forecast. But in terms of impacts on your weather pattern, the evolution of the Atlantic has more of a significant impact on Europe because your weather is coming from here to Europe or from here to Africa. When it comes to North America, absolutely there's a factor. It influences the potential for negative NAO and the potential for having a feedback effect and keeping that feedback effect, which impacts both Europe and North America. But in terms of the overall pattern evolution, if you have a sea surface temperature anomaly that supports a screaming polar jet stream from Japan to North America, then it doesn't matter what's going on in the Atlantic, because any block that tries to develop is just going to get ripped apart by a screaming polar jet stream running right across the country. So that's why it's more, I wouldn't say, yeah, it is basically more important, because it's very hard to overcome that in terms of influences. Let's see here. Do you know of any websites where you find a free graphic of EPO charts? Absolutely. Let's see here. I believe ENSO. Yeah. See, ENSO, if you search on ENSO, okay, look for weather teleconnections. You'll be able to find that pretty easily on ENSO for your model needs. I mean, honestly, do a search for EPO NCEP data, and you should be able to find that for free. Do the MJO phases mean the same thing in the fall and winter? No. The MJO phases, as you move through fall, winter, spring, the influences in terms of weather impacts changes. Where that convection is really doesn't change all that much, but it gives you a good idea. Like, what you want to do is study the cold season and warm season, okay? And that's pretty much how you have the MJO split in terms of influence. So, for example, the MJO gives you a good idea on the potential for tropical convection and where the potential for increased favorability for tropical systems to develop. The MJO gives you a good idea in the winter where East Coast cyclogenesis is more likely to happen, and for colder conditions. You don't want to use the MJO alone. You want to use it as a combination with other factors to understand forcing mechanisms throughout the entire atmosphere. A lot of people, they get into a bad habit of focusing in on one feature and acting like as if that is the dominant and only feature in the entire atmosphere. In reality, the atmosphere is a combination of a variety of factors that not only interact with each other, but then changes each other's influence on the weather pattern because of that interaction. So you have to look at twofold the influence and the interaction of these features. Let's see, first major snow average December 7th. I would not. Well, all right. First of all, okay. So the question is, hopefully Central Park gets first measured snow on average December 7th. Hopefully we get December snow extended down to Lakewood. Lakewood and Central Park, New York are vastly two different climate zones. I wouldn't make any comparison between the two. Or you're just going to end up being very disappointed. The average, not typically in El Nino years. You're more likely to see that in La Nina years. La Nina years, you typically see a colder pattern in November and December. And then as you move through January with the with the southeast ridge building, you typically start to move away from your winter pattern, and then you get an early spring typically. With El Ninos, it's the exact opposite. So I would not, again, as I said, we have to deal with the environment that we are in. So I wouldn't go that way. Let's see. Snows in Lakewood area early before the beginning of December. Let's see here. A lot of questions about Lakewood. All right, let me put it to you. Oh, okay. That might be why. Let me put it to you this way. There is no sign in any way, shape, or form on any of the model guides for snowfall in Lakewood in November or early December. So we'll just put it like that. This is not the pattern you would look for. Okay, let's see. Is Super El Nino still technically possible? And what would be some of the indicators that could signal that development? No. It's just no. The idea of a Super El Nino died like 4 months ago. I don't know why there's some people who are still continuously trying to push it. This right here, the amount of change that you would need in this index to support the idea of these. Again, this was all the way up to about 1.8 by this point. We're at 0.3. That's a huge change in this index. That's a huge difference. We're not even near your moderate El Ninos, let alone super strong Power Ranger attack Super El Nino. I mean, it just isn't. It isn't there. It just isn't. The data isn't there. The only thing you got going for you is the sea surface temperatures in Nino 1+2. But the rest of the atmosphere is saying no. And again, if you compare it to other super strong El Ninos, some of the historic ones, as you can see on the chart here, we're nowhere near that. We're just not. That's just the data. What you'd want to see is for this to be somewhere in this ballpark here. As you can see here, we're nowhere near that. It's like saying that, hey, we have a guy who's playing baseball and he's batting 225, but hey, he could bat 400 if we sprinkle fairy dust on him. That's it. Other than that, no. How could the cooler, more southern waters influence things? Nothing for us. It's in the southern hemisphere, not anything directly. Do you think that warmer, more zonal pattern could allow for a better winter weather pattern in January? Too early to tell. Do you think there will be late January through?
This upcoming winter.
There will be a thaw. Oh, a thaw. Okay. Though I'm guessing thaw. I mean, it's too early to tell. Is it possible for a coastal storm forming by Thanksgiving? There's definitely a possibility of a coastal storm. What I showed was an indication of. Here, let me see. Let me show you. This is a cool thing about using the ensembles, is that you can pull it up. And again, you never take any of this stuff verbatim. That's the word I was trying to find there. You never take this verbatim saying, oh, this is exactly what's going to happen. I know a lot of people like to take something like this, especially if it shows snow in their backyard, and share it all over social media. But certainly this far out, you never take this verbatim. But let's take a look at some of the options here. So what you do is that you look at each solution, and you can see each one. What's telling me already is that there's a lot of volatility, but a very active pattern at that. There's a lot of short waves running around all over the place, producing different solutions depending on their interaction. So when I look at this, what it tells me is that, hey, look, this could be, here's one of your coastal storms. This is going to be an active pattern for around Thanksgiving. So if you have travel plans, you're going to see grandma's house or something like that nature, um, I would be prepared for some unsettled weather. I don't know the details. No one knows the details just yet, but this certainly looks like an active pattern. What this tells me here is that we have an active subtropical jet stream during this time period, and it's going to be capable of interacting with the polar jet stream. What that produces, I have no idea yet, but it tells me that there is a potential here for some sort of storm activity. No, La Nina has no influence on this pattern. And I would in no way suggest doing a location specific amount of snow for any location for this season. I know that there's some people that do that, but I'm not. Look, I'm not that good. I'm just the science isn't there for it. I mean, I could throw out a number, 40 inches. We'll see if it works, and go from there. So basically, what you do is you kind of take the average and add plus or minus a couple of inches. But that's typically what you get when you get that type of data. What is the latest QBO data? Latest QBO is, let's see here, where was it? I had that up here somewhere. Here we are. It's easterly. It's easterly, and it's at a pretty moderate strength. Let's see, right about minus 15 to 20, so it's pretty good strength. Heat transport's starting to develop, but it's not there yet, and I don't expect it to be. Where are the warmest ENSO subsurface temperatures at this point? Let's see here. I know I got that data around here somewhere. And here we are. All right, let me. Okay, so there's the upper ocean heat anomalies. You can see they're pretty much stable. So El Nino is not going away anytime soon. And this is the subsurface. And notice the change from the past couple of weeks. Here we are in early September. And notice all your focus was here in the eastern zones. And I've been talking around this time, I was saying, hey, look, watch for a shift. And as you can see, we have been developing that shift to more of a basin wide. And that's becoming very clear in our subsurface anomaly. So you can see that whole evolution taking place pretty nicely in terms of forcing mechanisms on the atmosphere. Let's see here. Do you think that we get this cool weather thing called Alberta Clippers? Alberta Clippers are always possible, especially with the amplified polar jet stream. I wouldn't expect anything significant right now. We'll see maybe in mid-December. That's probably when we start to look at. When it comes to snow, all right, if you're in the Poconos or Catskills, you can get definitely some mixed precipitation events, some light snow events, maybe a wintry mix, maybe change over to snow in early to mid-December. Sometimes you could pull it off on the coast, but those are really, really rare. Really rare. And remember, when New York City picks up its first snowfall, that could just be a trace. So here's your flurry. Boom, there you go. Which could be after a major rainstorm, So again, you have to understand what some of these averages mean and how they work out. All right, let's see. Lakewood will get no snow now. How about that? Negative.
Okay.
When will you have more details about weather forecasts for Thanksgiving? Well, typically, my forecast, the way I look at it is that 10 to 15 days out, you look at the theme. 7 days out, you're still in the theme level, okay? When I say theme, 10 to 15 days out, just the overall pattern. 7 to 10 days out, get a little bit more idea on the theme, get a little bit better idea on the timing of potential window. Once you get under 7 days, that's when we start to add in more details. Anything before that is pretty much just hot air. No pun intended. And then once I get under 5 days, 120 hours, that's when we can really, really zero in on precipitation type, intensity, get a little bit better idea on the timing. Under 66 hours out, that's where we really lock in timing and really get things rocking and rolling. So I would say again, for around the Thanksgiving time period, wouldn't cancel plans or anything of that nature. Just keep it in the back of your mind that, hey, look, it's going to be a little bit stormier, a little bit cooler possible, definitely a better potential for some polar air masses to interact with our pattern, and be prepared accordingly. That's what I would suggest. Let's see here. We have some great questions tonight. Absolutely. Izzy is very active tonight. Very active. Let's see here. Do you think more rain to snow events this year or snow to rain? I have no idea. I have no idea. It just depends on each storm. And the pattern that sets up. That I have no idea about that one. I would say that it's definitely going to be more events than what we had last year. And honestly, I had one person ask me, I was at the gym and working out, and the guy asked me, like, is it going to snow more than last year? I'm like, well, that's easy. Yes. He's like, oh, how do you know? It's because we didn't have any snow last year. So I get a flurry. We're set. So I'm pretty confident about that. I don't like doing details in long-range seasonal forecasting or details on what to expect 8 weeks from now in terms of the amount of snow or the trends of the precipitation of individual storms 8 weeks out or 6 weeks out because it's the science isn't there, and really all I'm doing is lying to you at that point. Well, oh yeah, totally. I expect more snow to rain. No, I don't. I have no idea. No one knows. So it's kind of. I know that you'll probably get an answer from some individuals and say, "Oh yeah, totally. We're going to see more rain to snow events," but based on what data, So what I always try to do is focus on. What I'd like to do is I like to show the observations and saying, these are the observations, this is how it usually drives, and here's the model data. The reason why I do that is that it's evidence-based, okay? When you go with model data and then try to cherry pick the observations, then what you get is basically, what's the word I want to use? Bias, confirmation bias. There we go. Where you're just trying to find data to fit the model guidance. So if you go with the observations first, and this is how I would suggest doing this for anything science based. You get the observational data first, and you study that observational data first. And then you put that through a mathematical equation, which is what a model is. A model is nothing more than the mathematical equations based on forcing parameters. Okay, so you take the data, you put it in the equation, and there is your forecast based on that output. But if you don't understand the initial data you're putting in, which is what I try to show you here, then basically you don't know whether this is something that is reliable or if it's something that I'm just cherry picking. So it's always important to start off with the observations first and go from there. Thank you, Izzy. I appreciate it. Dun, dun, dun. Do you have a
Models, yeah.
Do you have a favorite model? Do you just think probably best use to blend it of it all? Um, I typically like to use the best model based on the observations. To be honest with you, the past couple of years, that's more often than not been the European or the European Ensemble guidance. In fact, the European and European Ensemble guidance has been ranked as one of the number one model forecasts to use um, week after week, month after month. With that said, it's also always important to study the GFS and the Canadian and all the other guidance to take a look at it to see, hey, look, maybe I'm missing something. Maybe there's a piece here that is showing more convective feedback than not. It's also important to use the mesoscale models for specific forecasts. So let's say I have the European guidance suggesting that a storm is going to come in and there's going to be rapid development and it's going to develop on the coastal waters. So what I do after that, after we know about the storm evolution, the cold air coming in, all that good stuff, then I use the NAM and the HRR guidance as we get closer to the storm to try to pick out the areas where we get mesoscale banding. You see, you don't want to use mesoscale banding for the European guidance because the European guidance is a synoptic model, large tool, and mesoscale models are small tools that answer small questions. Reverse wise, you don't want to use the NAM guidance to answer synoptic scale questions. So you use the models as a combination depending on the type of data you're looking for and the type of question you have. So if I'm trying to understand, hey, where are the mesoscale bands and the heavy snow bands going to set up in this storm, then what I want to use is the synoptic view on the European or the GFS if you're using the GFS, and then you combine that with what the NAM and the HRR or the RAP is seeing, and you take that data and you put it over the European data, the synoptic data, and you see whether or not the lifting parameters match. But what the NAM is going to do is give you a better resolution of the influence of those lifting parameters. So then you combine the two, and that's how you start to create the basis of your forecast. What you want to do when you're doing your forecasting is first have a general idea of what the forecast is based on the observations you're seeing. So, for example, if you see that it's 45 degrees with a dew point of 39, and you have a model guidance that's forecasting 3 feet of snow in the next 12 hours, then what you're going to have to look for is, well, where's my strong cold air transport coming from? Because current conditions right now are nowhere near that supportive for that forecast. So you see how it's important to look at the observations first in order to pick out error and to weed out poor model guidance.
Don't answer.
Let's see here. So yeah, I mean, I'll continue to keep an eye on the Thanksgiving forecast, but probably next week I'll be able to provide a lot more details on what to expect. And then probably by next weekend, we'll actually have a pretty good idea. We'll be able to knock down exactly the timing of impacts and what to expect for your travel. Usually it's the Saturday before Thanksgiving where I'm able to put out a Thanksgiving forecast. Let's see here. It's 8:50, almost 8:50. I'm going to take one more question before I lose my voice, and then we'll call it a night. So let's see here. I'm going to take a question from the premium chat. Let's see what we got here. Let's see. I'm looking for a good one now. And we also have YouTube here as well. We've had an excellent job, by the way. Absolutely excellent job with the questions tonight, guys. So let me go over and just do a recap here. Currently, right now, and I'll just put myself here. Okay, currently, right now, everything that we've been looking for in terms of what we were talking about with the winter forecast is evolving as expected. The El Nino event is basically a weak to moderate one in terms of the atmospheric influence, in terms of sea surface temperatures, because of what we're seeing in the Pacific. You're seeing a shift from a strong east base to a basin-wide El Nino event, but it's only strong in terms of sea surface temperatures, not in atmospheric forcing. Meanwhile, the polar vortex is strengthening as you would expect for this time of year, but there are signs of seeing that heat transport. Certainly, the QBO remains negative and likely to continue to do so. And we are waiting to see the heat transport. Once we start to see the EP flux really start to get its act together, which I'm expecting as we head into December, that is when we'll start to see that interruption. Right now, it's not supportive of that yet. And the reason why is because typically in El Nino, it takes a little bit of time for that process to get going. But once it does, I think it's really going to make an impact, especially with the negative QBO that we have, okay? With all that said, active pattern continuing through November right now because of the interaction between polar and subtropical jet stream. We have a lot of sheared short waves, so they're generally weak. Towards the end of the month, yes, around Thanksgiving, there's a good chance of seeing some sort of storm trying to organize itself, but we don't know the details just yet. And in the meantime, we continue to see some long-range model guidance, and again, like the European monthlies, continue to illustrate and suggest January and February are going to be the time periods that we're really going to be active around here. So that's what we're going to look for. And that's generally been the winter forecast as well. December is your warmest month. January and February is when we see a lot of activity. So a lot of the observations point to that taking place. With that being the case, looks like we got all the questions. I am going to shut it down for the night. Thank you as always for joining. I really appreciate it. And thank you again for the outstanding questions. And as always, stay safe out there.